I'd like to say it's a pleasure to talk to you guys. I understand you are starting a course in oceanography, so I will focus my talk a little bit on that. Of course, I also want to give you the big picture of what it means to fly to space on the International Space Station, and a little bit about my path becoming an astronaut. So can get started. So I grew up in a place in Italy, in the mountains, in the Alps, where at least back then we used to have a lot of snow. So that was a typical winter of my childhood. But I also grew up dreaming of starships, and some of them were real ones, like the space shuttle, and some of them were not quite so real, like the Starship Enterprise. And both those things kind of filled my dreams, so that growing up as a girl, a teenager, and then a young woman, I also developed more mature interests for science and technology and engineering. After high school, I went on to study aerospace engineering. So I left my country, I left Italy, I went to study in Germany at the Technical University of Munich. And I did some pretty extended study periods in France and in Russia. And then after I graduated in engineering, I actually got a chance to join the Italian Air Force. So I came back to Italy. I was trained as a military pilot until one day the European Space Agency announced that they were recruiting new astronauts. And of course, I had to participate, especially in Europe. It doesn't happen every day. It was back in 2008, and now 10 years later, it hasn't happened again yet. So I think it was a good choice to take that opportunity when it came back then, and I was lucky enough to be selected as an astronaut to join the European Space Agency with 5 other young Europeans of mixed backgrounds. Some of us are pilots, some of us are test pilots, some of us are pilots and engineers, some of us are pure engineers, and one of us is a pure scientist, Alex Gerst, who will fly to space station for his second time in just a couple of months' time. So after we were selected, we started a crazy life of training around the world. So I've just put up this medley of pictures. I'm not going to go in detail into all of them because that's not the topic of our conversation today, but it's just to give you a hint of the variety of training that we undergo to eventually fly to space. Again, throughout the world, lots of the training takes place in Houston, in the US, a lot in Russia, in Star City near Moscow. Some of it here, where I am today, at the European Astronaut Center in Cologne, a little bit in Tsukuba, Japan, and a couple of weeks of training also in Canada. Those are all the partners of the International Space Station, and each partner is responsible for training at their locations for the components that they provide to space station. So after about 5 years of training, I had a chance to finally fly to space for what was the Expedition 4243 of the International Space Station. In Europe, it became known as the Futura mission. And it ended up becoming quite an extended mission. Typically, rotations on the space station are 5.5 months. In our case, towards the end of the mission, we got extended and we got to stay an extra month. So overall, my crewmates and I spent 200 days on the International Space Station. So, and this is how it all started at the Baikonur Cosmodrome. It's in Kazakhstan, a very legendary place where really the human exploration of space started, with the historic flights of people that I'm sure you've heard of, Yuri Gagarin, Valentina Tereshkova, first man and first woman to fly to space. They took off from this very same cosmodrome on a rocket that looked not much different than this one. And we were at the very top of this rocket with our little spaceship. It's very small. It's about 7 meters from the front to the aft. but the space inside where we can actually sit during ascent and during re-entry. It's only one tiny part of it. It's called descent module, and we are kind of crunched up in there, knowing that of course during launch and re-entry we're not dressed in a t-shirt like that. That was just a verification event before re-entry, but we're actually wearing a spacesuit like this. So I have great admiration for tall people. I'm small, so I kind of fit in there quite okay. I think tall astronauts are the ones who really deserve credit for being very, very motivated to fly to space if they want to crunch up and find space in the Soyuz. These are my crewmates. So from, I guess, your left to right, Terry Wirtz, a NASA astronaut. She was a veteran of a previous space flight on the space shuttle. And in the center, Anton Shkaplerov, our Soyuz commander. That was his second flight. And I actually hate him because he is in space again right now. No, I'm very jealous, but that's okay. Hopefully I will have my chance for a second flight eventually as well. So we flew to space on this rocket. It doesn't take longer. We get to orbit in about 9 minutes, and then we basically start flying around the Earth once every 90 minutes for 4 times, so 4 orbits, until we catch up with the space station, and we perform a rendezvous and then a docking. And this one, of course, is the International Space Station. I call it humanity's outpost in space. It's an amazing facility, certainly the greatest peacetime, at least, engineering project ever undertaken. It was built over the course of 10 years, piece by piece. At the time shuttle launch or on a Russian rocket, every launch would bring one piece to space, and then they would be joined together up there on orbit, and they all stick together. So that's a testament to great interface control. It's huge. If you imagine it sitting on the ground, it would be as big as a football field. It kind of has, you know, this cross shape that you can maybe recognize. You know, one line is made of those can-shaped modules. They're pressurized modules. That's where you have air inside that keeps astronauts alive, allows them to live and breathe up there on space station. And the other axis is called the trough. It's unpressurized. It's open to outer space. That's where we store spare parts, spare components for external equipment, and also, of course, they serve to install they allow us to install the solar panel at a certain distance from the main stack of pressurized modules. Again, the product of a big international corporation, and about 10 years time to build it to the current state. And it has been inhabited for quite some time, actually. There have been crew members on board of the space station since the year 2000. So I don't know how old you guys are, but I guess you're probably close to that age. I mean, if a couple of you were born after November 2000, then you guys haven't spent a single day without a human being up there in space. This is the full crew. So when we got there, you see the 3 of us at the bottom. 3 people were already up there waiting for us. It was kind of good because they had been up there in space for a couple of months at that point. So they were veterans, so they knew how things worked. They could help us get up to speed with the work and the daily life up there on space station. So they are Sasha, Butch, and Yelena, 2 Russians and an American astronaut from NASA. This is one of those can-shaped modules that I mentioned, one of those pressurized modules, a little bit of a closer view. This is what I call a piece of Europe up in space, because it's the European laboratory. It's named after Columbus, and inside it's full of equipment that allows us to do research. And the reason we are interested in doing research up there is, of course, because we float. Everything floats, and everything floats because we are in a state of free fall around the Earth. And so, as though gravity does exist up there, and it's still quite strong, not a lot less than it is on the surface of the planet, about 90%. So if you were standing still on top of a skyscraper that is 400 kilometers high as the space station, and you would just be standing still on top of it, you would still weigh about 90% of your weight. So the reason why you feel weightless up there is because you're constantly falling around the planet. And technically speaking, we call this condition microgravity. And microgravity is a very interesting place to do research, both on biological systems. So it can be cells, it can be bacteria, it can be small animals, it can be plants, it can be the human body as a whole, and also on physical systems. Disciplines that are interested in doing research in microgravity range from combustion science to fluid physics to metallurgy, material science. So a lot of disciplines, a lot of research directions that have an interest in exploiting this particular platform of microgravity. And it's really the only way to do research in microgravity for extended periods of time. If you're happy with shorter times, you could use a drop tower, where you just fall for a few seconds, or you could do a parabolic flight, you know, airplanes that fly a parabola in the sky and have weightlessness for about 22 seconds. For a few minutes, you could use a sounding rocket. But if you want microgravity for an extended period of time, then the only way is to be in orbit, so on the International Space Station. And this is just one of many examples of experimental protocols I did up there. This was on immune cell cultures and how they adapted to microgravity. I'm not going to talk to you any further about science up there, and not because it's not interesting. It's extremely interesting, and I encourage you to read up. But it's just not the topic of our conversation today, so I will leave it at that and move on. And all right, and so in space we have this beautiful module, which is every astronaut's favorite place. It's called the cupola. So you've seen this can-shaped modules. They mostly do not have any window, or if they have a window, it's actually a very small one. So you could see if it's facing nadir, so towards the planet, you typically just see, you know, like a little piece of a continent, or of an ocean, of mountains, of desert, whatever it is, cities, that is kind of like flowing beneath you, kind of like a river, which is cool by itself. But then if you go to the cupola, you have this marvelous view of actually of the surface of the planet from one horizon to the other. And if you've seen pictures, I will show you some of the view from space. Most of them have been taken from this module, from the cupola. This is a picture taken as a fisheye, with a fisheye. Kind of shows you the surface of the planet. Of course, I didn't take it, by the way. It was taken by John Pettit, a great photographer, astronaut photographer. And I think I did take this one. So this is a beautiful view of an ocean with just a little bit of a hint of the moon glint. This is very typical, you know, if you go out to the cupola at any given time, just at a random time throughout the day, then of course the likelihood is quite big that you will find yourself overflying the ocean, just because most of the surface of our planet is really made of big extenses of water. And one of the nice experiences is actually just sitting there and floating over the water and the clouds, and then sometimes you will, sometimes, go back. And then sometimes there will be like a little island popping through the clouds. Some of them are inhabited, and some of them are so remote that there's probably typically not a human being on there, or maybe there was never a human being on them. But just to give you an idea, these are, I guess, the 4 ground tracks of 4 orbits of the International Space Station. So I would like to give you some numbers here. I think I mentioned already the space station is at 400 kilometers. So it's really not very far from the surface of the Earth. If you imagine the Earth being the size of a billiard ball, then the space station would be flying at a crazy speed around it, but at a distance of only like 4 millimeters. I don't know what that is, a quarter or an eighth of an inch, so very, very close. But of course at a very high speed. This is what keeps us in orbit. This is what prevents us from falling back onto the planet. So every distance from Earth has its typical orbital speed that allows you to stay up there in orbit. And at that distance of 400 kilometers, the orbital speed is about 28,000 kilometers per hour. I think that's around 17,000 miles per hour. So we fly around the Earth once every 90 minutes, an hour and a half. And every line that you see up there is physically the ground track of one of those orbits. The orbit is inclined 51 degrees with respect to the equator. It means that if you see it flat on a map like that, the highest and the lowest that you can go in terms of latitude, let's call it northern latitude and southern latitude, is 51 degrees. Everything further north or further south of that, you will never overfly because that's just the latitude is just too big. But every point on the planet within 51 degrees north of latitude and 51 degrees south, you will eventually overfly because the orbits, they move on the planet. Of course, in an hour and a half, the planet rotates, and so the next orbit, you will be shifted towards the west. And there is also a phenomenon called orbital precession, so the orbit will slide also because of that. So eventually you will overfly all of the planet if you are patient enough. And of course, because you're going around the planet once every 90 minutes, so roughly 15 to 16 times per day, you also see sunrise and sunset 16 times per day, which is one of the most beautiful things that you can see up there. It will start. This is like the space station. If there are no lights, you can just recognize a little bit of the space station when there is the first light coming through the horizon. This is a typical sunrise or sunset. It's a very short moment. It's about 5 to 6 seconds when this kind of like an egg yolk appears on the horizon after there's been this blue stripe for a while. And then basically it floods the space station with this bright orange light, which is almost like everything is on fire. And then you start seeing basically the surface of the planet being overtaken by light slowly. It takes about 10 minutes. So you basically see this line which separates night and day. We call it the Terminator, that kind of rolls over the planet and kind of chases away the darkness, or vice versa, of course, if it's a sunset. Again, this is a picture of the Terminator. Of course, it's a very special time of the day because the shadows are very long, and so it gives a very special feel to the view from the window. It's interesting. There are a couple of times throughout the year when the orbit of the space station is aligned in such a way that basically we are riding along the Terminator. So basically, for a few days, there will be no proper sunrise and no proper sunset, but we're kind of like all the time in between, riding along that line. So if you look to one side, it's going to be dark, and if you look on the other side, it's going to be day. But of course, a very shady gray, kind of living, I guess, kind of like a wintertime day in very northern latitudes. The energy up there comes from solar panels, as I mentioned earlier. So this big panels on the extremities of the truss, they provide all the electricity that we need up there. So the solar panels, of course, as we fly around the Earth, and as the Earth flies around the sun, they have to track the sun. So they have to continuously rotate to make sure that they are always oriented in the most ideal conditions towards the sun to be able, of course, to capture the energy of the sun and convert it into electricity, to charge the batteries and to provide directly to the users. The space station itself, however, turns. So basically, we're not inertial in space. We don't just keep the same attitude, but as we fly around the Earth, we kind of want to fly, let's say, with our belly pointing towards the Earth all the time. So we call this LVLH attitude, local vertical, local horizontal. So basically, the space station, as it flies along, it flips over. It does a 360 degrees pitch in one orbit. Okay, you know, it kind of flips over its nose to make sure that it tracks the curvature of the planet. And so if you're looking off to the side, and if you do a long exposure picture with the camera, you can do marvelous pictures like this one. And I forgot to write, this is also a picture by my colleague Don Paget, this great photographer. And you can really see the traces left by the stars as they move in your view. And on the bottom, these are like the lights on the surface of the planet as the space station flies by. So I'm going to share a few views of the surface of the planet from up there that I could enjoy from this beautiful vantage point of the cupola. One of the most amazing things that you can see up there are, of course, auroras. I don't know, maybe some of you have seen auroras on the Earth. I have not, actually. I only saw them from space. And at least from space, they're amazing. I mean, you have the feeling that you literally fly through them sometimes. And they're very difficult to capture on a photograph because the photograph is always a little bit blurry because they're always dancing. You know, they're moving very fast. They're doing this amazing dance. Another very special thing are noctilucent clouds. You don't see them very often. I actually think I took this picture and I saw them for the first time on my day 199 on board, so at the very, very end of my stay. But they're very high clouds up in the stratosphere, and in certain conditions, they're basically illuminated from beneath, from the sun, which is still beyond the horizon, and they make this beautiful effect. Again, planet is very much covered by water, so this is another view of our Earth oceans. And as I said, sometimes you just have an atoll or an island all of a sudden appearing and peeking through the clouds, and again, you never know whether human beings have actually ever set foot on them or not. These are the Caribbean. It's very, very unique. Every astronaut will recognize this because they have this peculiar texture and shape and especially color to it. And of course, water can be in the form of snow and ice. This is a place which is very dear to me. It's the Alpine Arc, which is kind of like follows the border of northern Italy. So this is where I was born and I grew up. Then, of course, there's lakes. Sometimes, you know, if you have an extent of land, especially during the day, where you do not see the cities very easily, it's sometimes really hard to understand where you are. For example, in Europe, in what country is this place? You know, because Europe has a lot of countries in a pretty small space. And then, of course, the shape of a lake will help a lot. Of course, if you see this is Lake Balaton, you will know that you are in Hungary. This is the Aral Sea over in Asia, and this is an example of actually seeing the impact of human presence on the planet, sometimes a pretty heavy impact. I believe it used to be the fourth biggest sea in the world, and now it's reduced to very little surface and very little water, mainly due to, I believe, diverting water from the rivers flowing into it, which is, of course, a pretty big impact for the ecosystem and the people. This is in the U.S. It's the Great Salt Lake, and if you can see it, I found it very bizarre from seeing this from the space station. It's actually kind of cut in two parts with a very straight line, and the two parts have pretty different color. So I had no idea why that is. I know this now because I looked it up, but I will leave you with the question, or maybe you know already. Otherwise, you can also try and find out why it is so unique. And of course, there's rivers. This is the river Nile in Sudan. Following the rivers is interesting because you know, lots of especially big rivers, they have been the cradles of early human civilizations. So it's always fun and interesting to see them from space, and of course that's very true of the Nile. And of course, when we're talking about water and big water bodies and oceans, that cannot be unrelated from big weather phenomena. The humidity and the heat and the energy which is stored in the oceans is bound to create big weather phenomena. Sometimes it's just found cloud formations like this one, or this one. Or this one with the very long shadows of being close to the Terminator. Big thunderstorms. This is close to Bangkok, I believe. Thunderstorms from space are great. You cannot capture that in a picture, of course, but because you see quite a big, not a huge, but quite a significant chunk of the Earth. So if you're overflying a big thunderstorm, for example, in Central Africa, it's very typical. Then you just see flashes all the time. I mean, it's incredible. It's like, you know, being in a nightclub of the 80s, which you obviously have never seen, but very, very cool. And then you see big cyclones, and those are really, really impressive because they really give you the feeling of all the energy that is stored in them. Which is of course fine as long as they are in the ocean, uninhabited waters, but as you know, they can become very dangerous when they come to shore. You can see very clearly the shape and the structure of the cyclones from up there, and of course the eye. This is a closer view of an eye of a cyclone. I was actually really lucky once. I could take a picture just by chance. I took this series of pictures of this cyclone. I think it was called Bansi or Maizak, I don't know, but at night, and in this one you can actually see thunder or lightning lighting up the eye, which is a pretty lucky shot. I think some meteorologists were really excited about this one. And then water plays with light, of course, especially at night when you have a nice moon. Then it's fascinating when you look outside of the window and it's actually completely dark, maybe a place where there are no cities, and so it's just pitch black. And then all of a sudden the reflection of the moon glint comes by, and there is a body of water, like a river like that, and all of a sudden it's there, this silvery-like surface. And then of course the moon glint moves on, and then it disappears, and it's back into pitch black. And then of course you have effects like this of reflections of the water towards the sunrise or the sunset with this almost pink glow that really brings out the shape of the continent. This is Greece. Some might recognize this three-finger shaped piece of land, which is quite characteristic. People also ask me about the moon. I mean, how does the moon look from the International Space Station? Of course, I'm really sad to disappoint, but it looks pretty much the same as it looks from Earth, which is to be expected because it's still very, very far away. From the surface of the Earth, the moon is almost 400,000 kilometers away, and the space station, as we discussed, is only 400 kilometers. So we haven't really gotten much closer to the moon. It's still out there, it's still very far. There were a few occasions where the influence of the moon became quite evident. Of course, in a solar eclipse, that's the case. We had an eclipse up there. We absolutely did not have any photographic equipment to take proper photos. So, of course, you're not supposed to watch the sun directly. That was basically pointing the camera without really watching, and to see if I could take at least some photographic proof that we saw an eclipse from up there. So this was the result. But the coolest thing I thought was actually seeing the umbra. So very far down there, you can see basically that's the shade or the shadow of the moon projected onto the surface of the Earth, which I thought was kind of cool. Water, of course, is very present in our lives as astronauts throughout, from training. We train underwater for spacewalks. This is really the only way that we have to be able to train in the 3 dimensions. So there is this gigantic pool in Houston, and in it, on this pool floor, lies a gigantic replica of the International Space Station in real size that you can see there. Water, of course, is also what we need inside this spacewalking suit to keep us cool. Otherwise, we would most likely overheat in most conditions. It basically flows in little tubes. I don't know, hundreds of feet of little tubes that are woven into this white undergarment that we have inside the big pressure suit. Of course, water can also be dangerous. A good friend of mine, another Italian astronaut, Luca Parmitano, did a spacewalk back in 2013, I believe, and he literally almost drowned. Which, of all the ways to die in outer space, is probably not on the top of anyone, was not on the top of anyone's list. Basically, there was a leak. Water from this cooling loop was leaking into his ventilation loop and was basically blown into his helmet with the ventilation air. And it gathered until it was quite a big blob and prevented him from hearing and talking at some point. So luckily, he got himself, with the help of his colleagues, he got himself back inside quite quickly, and everything went well. But definitely an interesting encounter with water that was not meant to be. We do train for water landings, but in the case of the Soyuz, that's actually an emergency situation. It only happened once in the history of the Soyuz, many decades of flight. But of course, we do train for it. Specifically, we train how to evacuate the descent module in case we land in water and there is a leak and water starts to get into the capsule, and then we have to get out. However, in case of the new vehicles that are in development in the United States, water landing will actually be the nominal landing. So if I ever get to fly on one of those vehicles, of course I will have to train for that. One example is the crew version of Dragon. This is a Dragon cargo vehicle, which has just been released from the robotic arm of the space station to basically re-enter through the atmosphere on the planet. And it does a splashdown in the Pacific Ocean. And the crew version of Dragon, which is in development now, will also do a splashdown, just as the Orion capsule, which is also in development in the United States for missions beyond low Earth orbit. It will also splash down in a nominal way, and that's why astronauts at NASA have been participating in evacuation and rescue drills for quite some time now. This is the big pool I showed you earlier, but in this case it's been used to rehearse an exit rescue scenario after a splashdown. How about on the International Space Station? Of course, water is very precious. We cannot go and open the tab if the water has run out. It has run out. So we make sure that we conserve it and recycle as much as possible. We also use we need water, of course, to drink. We also need it to rehydrate a lot of the food. Many of the food packages up there are kind of like that one that I have in my hand. Those are called Italian vegetables. They're not Italian at all, but that's how they're called. And you actually need to add water, hot water, and let it rest for some time before you can consume it and eat it. And then, of course, there's water that comes from sweating and from breathing that all goes into the cabin, into the air of the cabin, and needs to be recovered. So the air conditioning system actually recovers all of that humidity, and it gets into the recycling system, and it gets turned back into potable water. The same, however, applies for the toilet. So your urine gets turned into absolutely safe, odorless, and tasteless, well, flavorless water that you can safely drink. So right now we are able to close the loop, the water loop on space station to about 75%, which is not optimal, but it's already quite a good achievement. This is a component from the urine processing assembly. So this tank that I have there is physically filled with all the residues that we cannot recycle, like, for example, all the mineral deposits from the urine. So it's pretty bad stuff. We have to change. We have 2 of those tanks that we swap all the time, and I would often be tasked to take one of those tanks out and basically transfer the content into the big tanks of an ATV. ATV is this cargo ship. It was a European cargo ship, doesn't fly anymore, and basically had those tanks. They would come up full of water. As I said, we only close 70% of the loop, so we do need water supplies once in a while. So ATV would come up with tanks full of water. We would transfer the water to the space station, and then we would basically fill those tanks with all those residues that from urine that cannot be actually recycled. Water, of course, can be used to do some tasty beverages. When I was on space station, I actually had a chance to taste the very first espresso in space. And I got to taste it in a special cup. And the reason I show you is to mention again the liquids in space have a very strange behavior. Of course, there is no gravity, so what's predominant is capillarity and surface tension. And so again, Don Pettit, this very creative colleague astronaut of mine, he invented this cup. You cannot quite see it on the picture, but it has one side which is a very specific angle. And this angle allows or makes the fluid, the coffee in that case, flow out per capillarity. And that's important because if I put some liquid in a cup, some people think that we cannot use cups because otherwise liquid would go all over the place. Well, actually they wouldn't. At least it would be very slow. They would just stay as a blob attached to the walls of the cup. But of course, if you do like that and you try to drink, it doesn't flow out. I mean, they just stay there in the cup. And so this capillary action on this very specific angle on the side of that cup actually allows it to come out, and you can almost drink as though you were on Earth. Otherwise, of course, what we do with liquids is we keep them in pouches and we have straws that we just suck the liquid out with. So just wrapping up the story of my mission. So after 200 days, I got to wear my spacesuit again after having been up there for a long time just in my shirt, because it's a normal environment up there, normal pressure, normal temperature, about 22 degrees. Then when it's time to come back, of course, we do need a pressure suit. And this is our little Soyuz just after undocking on our way back to planet Earth. I don't have much time, just a very quick couple of words about the future. I have already mentioned Orion. I will mention that the service module of Orion, so the part which is not cone-shaped, but the part in the back with the solar panels, is actually produced in Europe. We do provide that component from the European Space Agency side to NASA. So that it's very much a joint endeavor to build this spaceship that will be able to send astronauts again beyond low Earth orbit, so beyond this very close orbit where the space station flies. For example, back to an orbit around the Moon. Another big component of this endeavor is SLS, the Space Launch System, a heavy lift rocket that should make its debut flight, or maiden flight, before the end of this decade. One of the possible things that we might decide to do beyond low Earth orbit hasn't been decided yet, but there's been a lot of discussions about it. It's a so-called deep space gateway. It would be a small space station which would be in an orbit around the moon and could serve as a starting point for other types of missions, for example, on the moon surface. So somebody might one day send us again a beautiful picture like this of the Earth seen from the moon. Talking about water, one of the considerations, if we brainstorm a little about possible human missions to the surface of the moon, one of the considerations which is made quite often is the presence of water. There is water on the moon. It has been found specifically in so-called cold sinks, so areas which are never exposed to the sunlight because they're at a very high latitude towards the South Pole, and they're kind of like inside a crater, so they're shielded from the solar light. And so one possible destination, one possible thought is to have a human mission in that area so that you would be able to use the locally available water. And then, of course, this is for now a little bit further down the line, probably a few decades, but maybe one day we will actually have a full-fledged facility like this one on our satellite. Now, when we talk to Mars, so going from boots on the ground in this whitish regolith, typical of the moon, to boots on the ground on this reddish regolith, more typical of Mars, of course, things become a lot more complicated. I think you might have heard about this concept of NASA in particular, the journey to Mars, and I'm not going to comment in detail on this chart, but I think I just want to show it to give you a very high-level idea of the fact that there are many intermediate steps to get there. Getting humans, especially on the surface of the planet, with a reasonable possibility of actually having them ascend back to orbit and come back to Earth is quite a complicated, quite a challenging endeavor, and depending how much money the international community decides to put on it, of course, it might take definitely a little bit longer than going back to the moon. I do want to mention though I'm a European Space Agency astronaut, so if I talk about Mars, I would be remiss not to mention ExoMars, which is this robotic mission. The first part of it, the orbiter, is already on orbit around the planet. The lander, which is on there, actually crashed, unfortunately, on its landing attempt, but was able to gather quite extensive information during at least the initial descent phase. And then in 2020, there should be the launch of the actual rover. And the interesting thing about it is that it will be able to drill into the soil. And that's, of course, very interesting in terms of looking for signs of life on the planet. It would be very difficult for life to survive on the surface, but a little bit further down the soil, we might be able to find traces of life, or at least past life on Mars. So for this type of image, so for getting somebody on planet Mars, it might be a while until that happens for real. But I think there's a lot of intermediate steps towards that final goal that we can all be really excited about. And I will end with what I call my perspective slide, which is a picture of all of us a few years ago from 1.5 billion kilometers away from planet Earth. We sent a robot out there, Cassini, in the start of the system, and then one day it turned around and it took a picture of all of us, and we are on that little dot in there. So I hope you were smiling on that day. Thank you.